This is SpaceTime, Series 23, Episode 81. Coming up on SpaceTime, discovery of a possible origin for mysterious fast radio bursts, the first exposed planetary core discovered, and Virgin Galactic to start space tourism flights next year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected mysterious signals known as fast radio bursts, apparently emanating from a highly magnetic type of neutron star known as a magnetar. The discovery, reported in the astrophysical journal Letters, could finally solve the mystery of fast radio bursts, extremely powerful blasts of energy from the distant universe, but lasting for just a millisecond. The discovery was made using the European Space Agency's Integral High Energy Space Observatory, detecting a unique mix of radiation bursting from a magnetar in our own Milky Way galaxy, something that's simply never been seen before coming from this type of star. Magnetars are a type of neutron star, the stellar corpses of stars much larger than the Sun, which have exploded as supernovae at the end of their lives. If the magnetic fields of these stars are intense enough, they become magnetars. When magnetars become active, they produce short bursts of high-energy radiation which typically lasts for less than a second, but makes them billions of times more luminous than the Sun. On the other hand, fast radio bursts were first discovered in 2007. They appear as transient events, pulsating extremely brightly in radio waves for just a few milliseconds before fading away, and are rarely seen again. Their true nature remains unknown, and no such burst has ever been observed either within the Milky Way, with a known origin, or emitting any other kind of radiation beyond the radio spectrum. That is, until now. In late April this year, SGR 1935 plus 2154, a magnetar discovered 6 years ago in the constellation Vulpecula following a substantial burst of X-rays, suddenly became active again. And soon afterwards, astronomers spied something astonishing. The magnetar was not only radiating its usual X-rays, but also in radio waves. The study's lead author, Sandra Magnetti, from Italy's National Institute for Astrophysics in Milan, says Integral detected the magnetar's burst of high-energy or hard X-rays on April the 28th. Launched in 2002, Integral carries a suite of 4 instruments able to simultaneously observe and take images of cosmic objects in gamma rays, X-rays, and visible light. The Burst Alert system on Integral automatically alerted observatories around the world of the discovery. This enabled the scientific community to act fast to explore this source in more detail. Meanwhile, astronomers spotted a short and extremely bright burst of radio waves coming from the direction of SGR 1935 plus 2154 using Canada's CHIME radio telescope on the same day and over roughly the same time frame as the X-ray emissions. This was independently confirmed a few hours later by the Survey for Transient Astronomical Radio Emissions 2 or STARE-2 observatory in the United States. Magnetti says it's the first time astronomers have detected a burst of radio waves resembling a fast radio burst coming from a magnetar. And the connection strongly supports the idea that fast radio bursts emanate from magnetars. It therefore also demonstrates that bursts from these highly magnetized objects can be spotted in radio waves. And that's useful because magnetars are increasingly popular with astronomers as they're thought to play a key role in driving a number of different transient events in the universe, from superluminous supernova explosions to more distant and energetic gamma-ray bursts. This is SpaceTime. Still to come, discovery of the first ever exposed planetary core, and Virgin Galactic to start space tourism flights next year. All that and more still to come on SpaceTime. Astronomers have discovered what appears to be the exposed core of a planet. The findings, reported in the journal Nature, provides an unprecedented opportunity to see inside the interior of a planet and learn more about its composition. It would take an impossible 2,900 kilometres of drilling to reach the Earth's core, and so the discovery of an exposed planetary core is considered a huge breakthrough. The only problem being it's not nearby. The newly discovered planetary core belongs to an exoplanet known as TOI 849b, which is orbiting a Sun-like star located around 730 light-years away. This exposed core is about the same size as the planet Mercury in our solar system. Scientists assumed the core belonged to a gas giant that was either stripped of its gaseous atmosphere or that failed to form one early in its evolution. TOI 849b is an extremely unusual planet located in the so-called Neptune Desert, a term used by astronomers to define a region close to stars where they rarely see planets of Neptune's mass or larger. In fact, the study's lead author, Dr. David Armstrong from the University of Warwick, says the planet's strangely close to its star considering its mass. TOI 849b orbits its host star in just 18 hours and has a surface temperature of around 1500 degrees Celsius. The exoplanet was found using the transit method by NASA's Transiting Exoplanet Survey satellite TESS. The transit method measures the brightness of a star and then notes a dip in brightness to indicate a planet's passing in front of the star as seen from the spacecraft. Once scientists knew a planet was there, they further analysed it using the HARPS instrument at the European Southern Observatory's Le Cellier Observatory in Chile. This uses the Doppler shift or wobble method to measure the mass of exoplanets by measuring their gravitational pull on the star they're orbiting, causing the star to wobble ever so slightly. Now, the movement's only small, but an instrument like HARPS can detect the slight spectral movement as the star moves towards and away from us due to the gravitational effect of the orbiting planet. This allowed the authors to determine the planet's mass to be about 40 times that of the Earth. But that's surprisingly heavy considering the transit method confirmed the planet's radius to be just 3.4 times that of Earth. What it all means is that this is an extremely dense object, far denser than the Earth, and therefore most likely consisting of lots of iron and rock and water, but with very little hydrogen and helium. The lack of significant quantities of hydrogen and helium for such a massive planet is hard to understand, as both should have been accreted in large quantities as the planet formed. And it's this combination of factors which suggests that what's being observed is actually an exposed planetary core rather than a fully differentiated and completed planet. The study's co-author Christophe Mortacini from the University of Bern says the discovery fits in nicely with the world-renowned Bern model for planetary formation and evolution first proposed in 2003. The Bern model combines insights into the manifold process involved in the formation and evolution of planets, and suggests two possible hypotheses to explain why TOI 849b is not a typical gas giant, but rather an exposed planetary core. One possibility is that this exoplanet was once a gas giant similar to Jupiter, but it lost nearly all of its outer gaseous envelope through a gravitational tidal disruption after coming too close to its host star, by colliding with another planet, or maybe due to some large-scale photoevaporation of its atmosphere, although that probably couldn't account for all the gas that's already been lost. Now, of course, alternatively, TOI 849b could simply be a failed gas giant. See, once the core of the gas giant formed, something unusual could have happened, resulting in it not forming its surrounding atmosphere. Now, this could have been caused by something as simple as a gap in the protoplanetary disk that planets form in. That could have been due to some gravitational interaction with another planet, or that the disk simply ran out of material right at that very moment when gas accretion would normally occur. To find out more, Andrew Dunkley speaking with astronomer Professor Fred Watson.
This is an exoplanet. We've had quite a few exoplanets to talk about lately, but this one, it's unique. They have never seen one like it before. I know we're in the early phases of exoplanet discovery and we're finding more and more, and the numbers are getting up into the thousands now. But this one is one that isn't like any other that's ever been seen so far. And it has been suggested that it may well be a unique discovery. So what have we got?
I bet it's not unique in terms of it, the existence of these things outside in the wider universe. But as you're up,
I knew you would say that.
You're absolutely right. It is unique to our knowledge. There you are. That's the way to put it. This is a sun-like star, so you would expect maybe a solar system-like solar system around it, but not at all. What was discovered, and again, this is a discovery that comes from TESS, the Transiting Exoplanet Survey satellite, which looks for the dips in the intensity of stars as a planet passes in front of them. And so this particular object, which actually rejoices in the name of TOI 849b, TOI Test Object of Interest. So it was some time ago that I think they found this. You're quite right, where our numbers are well up in the thousands now. It passed 4,000. I think it was about a year last March when we passed 4,000. So it's well above that now. Anyway, TOI 849b surprised people because it's a relatively large object. It's an easy one to observe because it goes around its parent star once every 18 hours. That's its year, once every 18 hours. And so you don't need to observe over a very long period of time to catch many transits of the planet in front of its star. And that means you can refine its orbit very well. You can get a really good idea of its diameter. And it's basically a Neptune-sized object in its diameter.
Which would automatically make you think gas giant.
That's right. Yes, exactly. And Neptune-sized objects are interesting, but this is even more interesting because it's right near the parent star. Normally, you don't find Neptune-sized objects right next door to the parent star. Sometimes you find hot Jupiters, things that are bigger than Neptune, but not anything of this size. So that already made it interesting. But then the real clincher was when the second part of the research was carried out, because as you know, if you've got a planet that's going around a star and you're looking at it in the orbital plane, which you have to be for it to pass in front of the parent star and dim the light, it also makes finding its mass easier because you can measure the Doppler wobble of the parent star. You can actually look at the way the planet is pulling its parent star out of place using a spectrograph that breaks up the light into the rainbow colors and lets you see the barcode of information, which includes information on velocity, what we call the radial velocity. So astronomers did that. They measured the amount of wobble that the star was participating in because of the planet orbiting around it. And having done that, they could determine the mass of the planet. And that was the big surprise because it is 39.1 times the mass of the Earth. And that, when you combine it with its known diameter from the transit method, basically gives you a density which is very similar to the Earth's density. It's 5.2 grams per cubic centimetre.
So they're saying this is a rocky planet.
Yeah, exactly. It's a rocky planet. It's something
as big as a gas giant.
But as big as one of the smaller gas giants. So 2.3 times the mass of Neptune, a little smaller diameter than Neptune, and a density the same as the Earth. And that is a puzzle. It's not the most massive planet that's been discovered, but it's the most massive for its size, which means it's very dense. So it's a rocky planet. And that is where, the puzzle starts there. It's near its parent star. The comment that one of the researchers has made is that we don't normally see planets with this mass at these short orbital periods. A short orbital period tells you it's close to its parent star. And that leads to the suspicion that basically what we're seeing is the naked core of a gas giant planet. It's a gas planet kind of like Jupiter, but whose atmosphere has been stripped off. And it may be just where it is in its solar system that has done that, because the surface temperature is estimated to be 1,530 degrees Celsius, which translates to 2,780 degrees Fahrenheit. It's very hot because it's so close to its parent star. And so the thinking is that has caused the atmosphere to evaporate and essentially, become this naked gas giant core. Apparently, when you do the calculations, the loss of atmosphere that you would get from that heating, it's not enough to account for the fact that this has got no atmosphere at all. So people are suggesting that maybe other events have played a part, maybe collisions with other large bodies in that solar system, which we haven't found, or another interesting suggestion that it maybe started forming as a gas giant, but something prevented that from carrying on. Maybe there wasn't enough gas left in the disk, the protoplanetary disk around the star, or maybe there was a gap in the disk where something else had already formed, where there wasn't much gas to become an atmosphere. And so
sort of like your partner taking your blanket in the middle of the night, so it missed out.
It's a very good analogy. Andrew. That's right. Yeah, if your blanket's gone, you can't form an atmosphere around yourself. And that's basically what may have happened. So there are all these theories. And I think what's happening now is that astronomers are going to try and make more detailed observations of this object, TOI 849b, to try and find out one way or the other whether it's a gas giant that's been stripped of its atmosphere or a failed gas giant, one that never got its atmosphere. There's a nice quote actually from the lead author. It's a first telling us that planets like this exist and can be found. We have the opportunity to look at the core of a planet in a way that we can't do in our own solar system. There are still big open questions about the nature of Jupiter's core, for example. So strange and unusual exoplanets like this give a window into planet formation that we have no other way to explore. Very nice quote.
Yes, as he said, we've always wondered about what's going on down in the core of Jupiter and even Neptune and Saturn. This may be not the total answer, but it gives us maybe some better ideas if we study it as to what's happening in the gas giants in our solar system.
Exactly. That's exactly right. So that's how we do it. We look at other solar systems to find out what's happening in ours. It's paradoxical, really, isn't it?
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, Virgin Galactic to start space tourism flights next year. And later in the science report, South Australian company Vaxine about to begin Phase 2 trials of its new Corona-19 vaccine. All that and more still to come on Space Time. Virgin Galactic says it now expects to be carrying its first fare-paying passengers to the edge of space during the first quarter of next year. As the build-up to the commencement of operations continues, test flights using the Spaceship Two spacecraft Unity are also building up, with another successful glide flight from Virgin Galactic's New Mexico spaceport now completed. This summary from Virgin Galactic.
Right, stick forward, thumb off trim. 3, 2, 1, release. Clean release.
Our team arrived at our commercial headquarters, the Gateway to Space facility at Spaceport America, early in the morning to complete the final preparations for Spaceship Two Unity's second flight in New Mexico airspace. It was a typically beautiful New Mexico morning with a fantastic sunrise as our crew ran through the final checks. This test flight was conducted under a set of stringent operational protocols to ensure safety against COVID-19. These protocols included changes to the work areas and procedures to enforce social distancing as advised by state guidelines. On Spaceship Two Unity's flight deck were our pilots, Mark Forger-Stuckey and Michael Masucci, who have both previously flown Unity into space, while piloting our carrier aircraft was Nicola Petchile and CJ Sturkow. Once on board the spaceship, the spaceflight team conducted final checks before they were cleared for takeoff. The vehicles then took to the skies after a runway takeoff with Unity attached to VMS Eve. The mothership carried our spaceship to approximately 50,000 feet above Spaceport America. Once the vehicles reached release altitude, VMS Eve released Spaceship Two Unity. During this phase, Spaceship Two reached a speed of Mach 0.85. Our pilots performed a series of maneuvers with Unity designed to gather data about performance and handling qualities while flying at high speeds. With all test points completed, the pilots then brought Unity back down smoothly for a runway landing at Spaceport America. Our mission at Virgin Galactic is to open space to change the world for good. This glide flight took place during Pride Month, and we'd like to take a moment to encourage unity for all. Our crew were wearing masks in a variety of colors to show support. The future we're building here perfectly represents Stephen Hawking's naming of our spaceship Unity. This test flight brings us closer to commercial service and being able to open spaceflight for all.
Planned to take 2 more test flights of its suborbital rocket-powered space plane over the next few months, after which Virgin boss Richard Branson will ride the spacecraft for the first time, paving the way for the first commercial space tourism flights to begin. So far, more than 600 of the well-to-do have already paid more than $250,000 each for the ride. Virgin Galactic Spaceship Two spacecraft design is based on the original Burt-Rutan scaled composite Spaceship One spaceplane, which won the X Prize back in 2004 by becoming the first privately built reusable manned spacecraft to reach 100 kilometers in altitude, the official start of space, return to Earth safely, and then repeat the achievement within 2 weeks. Branson was so impressed, he contracted Burt-Rutan to build larger versions to carry tourists. The flight profile sees Spaceship Two take off horizontally from a conventional runway mounted under the center spar wing section of the unique twin fuselage White Knight 2 mothership, powered by 4 jet engines. White Knight 2 then climbs to an altitude of around 15.5 kilometers or 50,000 feet, at which point it releases Spaceship Two, which after a few seconds of freefall ignites its single hybrid rocket engine, quickly accelerating the spacecraft to over Mach 3 or 4,000 kilometers per hour. The hybrid rocket engine burn only lasts for about 70 seconds before MECO or main engine cutoff, but that provides enough momentum to allow the spacecraft to coast on a ballistic trajectory up to an apex altitude of over 100 kilometers, 328,000 feet, that official start of space known as the Kármán line, defined by the theoretical physicist Theodor von Kármán in 1956 as the point where aerodynamic surfaces can no longer control the roll, lift, pitch or yaw of an aircraft, forcing the use of reaction control systems such as rockets to maintain course and maneuvering. At this altitude, passengers will be treated to stunning views of the Earth below. They'll see the curvature of the planet and the delicate thin blue line of its life-giving atmosphere along the horizon. And they'll see the velvet blackness of space, despite their spacecraft and the Earth beneath being lit up in broad daylight. Add to that, there'll be the unique feeling of weightlessness for around 4 minutes. Then, as the spacecraft re-enters the atmosphere, its twin tail booms will be raised into a vertical feathered position, increasing drag and slowing down the rate of descent. At around 23 kilometers or 70,000 feet, the tail booms will be reconfigured back into their normal horizontal position, thereby allowing the spacecraft to glide back to the Earth for a conventional runway landing. Of course, Virgin Galactic's development suffered a major setback back in 2014, when the current prototype VSS Unity's predecessor, the VSS Enterprise, broke apart in mid-air, killing one of the test pilots after he wrongly released the feathering system during the ascent to space. Releasing the feathering system during ascent forced it to lock in place, at the same time putting huge aerodynamic loads on the airframe and causing the spacecraft to break apart. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. South Australian company Vaxine are about to begin Phase 2 trials of the new COVID-19 vaccine. The new study follows successful Phase 1 trials, which found the vaccine was both safe for humans to use and that it generated an immune response. The trials were conducted in consultation with scientists from Adelaide's Flinders University. Well, it looks like all the controversy surrounding the drug hydroxychloroquine isn't going away anytime soon, with a new study showing that it does cut death rates among patients with COVID-19. The findings, published in the International Journal of Infectious Diseases, found around 13% of those treated with hydroxychloroquine died, compared to 26% not treated with hydroxychloroquine. None of the patients had documented any serious heart abnormalities. However, patients were monitored for a heart condition, as it's routinely listed as being a reason to avoid using the drug as a treatment for COVID-19. 82% of those studied received the drug within 24 hours of admission, and 91% within 48 hours. The study was based on an analysis of 2,541 patients hospitalized between March the 10th and May the 2nd across 6 different hospitals. All the patients in the study were 18 or older, with the average age being 64 years. 51% of patients were male and 56% African American. Hydroxychloroquine is used as an arthritis medication, and it's also been approved to prevent and treat malaria. The study also found that those treated with azithromycin, or a combination of hydroxychloroquine and azithromycin, fared slightly better than those not treated with the drugs. The analysis found 22.4% of those treated alone with azithromycin died, and 21% of those treated with a combination of azithromycin and hydroxychloroquine died. That compared to 26.4% of patients dying who were not treated with either medication. A new study claims modern humans had begun colonizing the Americas 30,000 years ago, some 15,000 years earlier than previously thought. The findings, reported in the journal Nature, are based on stone tools discovered in a cave in central Mexico, together with a separate statistical analysis from several other sites in North America and Siberia. Archaeologists from the University of New South Wales and Oxford University uncovered nearly 2,000 stone tools and other artefacts in the cave over almost a decade. Both radiocarbon and luminescence dating were used to determine the ages of the items, which included bones, charcoal, and sediment DNA. Archaeologists say the items belong to a culture never before found in the Americas, suggesting a previously unknown and possibly failed colonization attempt. A new study claims there might be more to having a gut feeling than you realize. Well, sort of. The enteric nervous system is an extensive network of neurons and transmitters wrapped in and around the human gut, with the primary function of managing digestion. Scientists from Flinders University, delving into the complexity of this brain-like system to uncover its secret capabilities, have identified a particular type of neuron in the gut wall that communicates signals to other neurons outside the gut, near the spinal cord, and even up into the brain. You can read the findings in full in eNeuro, the Journal of Neuroscience. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.